Hey everyone, welcome back, and thank you for joining us again in our next discussion of statistics. Heading into our objective then, we want to be able to obtain a simple random sample. Well, first we need to introduce what is random sampling. Now, random sampling is the process of using chance to select individuals from a population to be included in a sample. The idea here is chance allows us to hopefully be unbiased on our end as much as we can. On the other hand, a convenience sample then is one which the individuals in the sample are easily obtained with limited or no randomization. This is a big deal to us here. A convenience sample means that the results of some survey are basically meaningless. We cannot trust a convenience sample. It opens up the door to too many different biases. So let's discuss our fundamental layer here that would be simple random sampling. That's where we have a sample size n, a lowercase n, which would be a vocabulary aspect for us. We need to remember that sample size would be lowercase n, from a population of size capital N, meaning we use capital N to represent population size. And in simple random sampling, we're going to obtain this sample in a manner where every possible sample has an equally likely chance of occurring or being chosen. For example, listing all individuals on separate pieces of paper, placing them in a hat, and picking the desired amount of pieces is actually a valid approach for simple random sampling. That's because each piece of paper representing an individual has an equally likely chance of being selected. So now let's discuss the steps for obtaining an SRS, that simple random sample. First, we need to obtain a frame which lists all the individuals in the population of interest. Then we'll number the individuals in the frame from 1 to capital N being our population size. Next, we'll use a random digit table, graphing calculator, or some software to randomly generate n, our sample size, numbers. For the sake of our classroom setting, we're going to go ahead and discuss this in terms of using the random digit table. Now, in order to use the random digit table, all numbers must have the same amount of digits. That is, if we have a population of size 85, then we look for numbers between 0, 1 and 85. We can't just use the number 1 because that would be one digit. We need each number to have 2 digits, which would be our population size. Next, we need to set the seed. In order to set the seed, we need to choose this initial point for the generator start. That way we can create random numbers. This is any non-zero number. It's usually given to us by the problem. Now here's the part that usually causes a bit of confusion. If a number does not fall in the qualifying range, it is simply skipped, and we move on to the next number in the process. Let's go ahead and jump into an example to elaborate on this a little bit, as it can be a bit confusing. We're told the 112th Congress of the U.S. had 435 members in the House of Representatives. They want us to obtain a simple random sample of 5 members to attend a presidential luncheon. Now we're going to use a random digit table to do this, so we're going to put the members in alphabetical order. After that, we're going to number the members accordingly. That means we're going from 001 up to our 435. Remember, that's because our sample size of 5 is coming from a population of 435, which means all of our numbers need to be 3-digit numbers. Next, we need to set the seed. Again, usually this is given by the problem. For this example, let's just go ahead and use row 3 and column 7. From there, we can match the generated random numbers or the selected numbers from the random digit table to the corresponding representatives. So let's take a look at our random digit table then. Remember, we said we're starting at row 3 and column 7. Now, before we head into selecting numbers, make sure we realize the gap that you see in between these columns is purely to make it easier for us to read. It does not designate anything in terms of the numbers. So as we select these numbers, we basically ignore that gap. I'll repeat that as we go through our process though. Just repeating one more time, our seed was row 3, column 7. That means we're starting at our 4 that we have here. I'm going to go ahead and zoom in to elaborate a little bit. So again, our seed was set at this number 4 here, as we go to apply it to getting our random sample. Our random sample needs to be 3-digit numbers between 001 and 435 as previously stated. That means the first number we're looking at is the 3-digit number starting with the 4, which gives us 419. Now 419 does fall in the range that we're looking for from 001 to 435, so our first selected member would be number 419. From there we move downward to find our next number, which would be 442. But 442 does not fall in our range of 001 up to 435, which means we need to skip 442 and continue down the column with the process. The next number we see would be 910, and of course 910 does not fit in our frame. As we continue downward, we've got 345, and 345 is in our frame, so that means we have our second selected number of 345. Continuing downward, we have 521 that does not fall in our frame, along with 590, 644, and 637, all of which do not fall in the frame that we're looking for. So at this point we only have two numbers, 419 and 345, representing members that are going to be selected for this luncheon. Process-wise, what we do is we go back to the top of the table, but remember we started at 419. So we cannot go to 321 because that would be before our seed. Instead, we need to move over to the next column, starting with 2 in column 10, and our next number would be a 274. Again, remember this gap between these large columns of numbers is purely to make it a bit easier for us to read. It does not mean anything in terms of the process. So our next number is a 274, and that does fall in our frame, therefore the next selected member is 274. Backing up a little bit to summarize so far, we have three selected members, numbers 419, 345, and 274 that fall in the frame, while skipping the other numbers we've come across that did not fall in the frame. Continuing with the process and moving down our columns then, 996 does not fall in our frame, 781 is also not in the frame, 931 is no good to us, 988 is no good, 842 is no good, until finally we come to our next selected member, which would be a number 233. Which means now we have 4 selected members, and we're almost there to get our random sample of 5. Continuing again with the process, 664 is no good, and 932 is no good, and that takes us to member number 250, which would be our last winner that gets to go to lunch with the president. So we have our list of generated numbers representing members of Congress. One little aspect there would be, what if we repeated a number just to reiterate the process? Remember, if we came across a repeated number, meaning let's say we had 419 originally selected, and then somewhere in this process we hit 419 again, remember we would just skip that 419 because they've already been selected and keep on moving with the process. And that would be how we use our random digit table to generate a simple random sample. And that's it for simple random sampling.